Good morning. How's everybody? Who's the first person just said? Who's that? They got off. They left. Good morning. I guess it'll just be the two of us. You have any questions about the homework I gave you all? What question would you like me to do to explain more in detail? No questions? Have you been to the blog? All right, does no one have any questions? I guess we won't have class today. Oh. My bad. Oh, so they can. So we don't have any questions. So I guess I'll see you all tomorrow. All right. Oh, that's it, Miss Mabry. It's just number 2. You don't understand? So you understand number 2? Okay. I'll still work it out for you. What's up, man? Okay, I'll still do number 2. So why I work number 2? If you have other questions, just let me know. All right. So if we do number 2, we're talking about the third root of a number. Third root of x. plus 2. So since this number is on the outside, this is your parent function right here. This is what you're going to start with. And then once you graph the parent function, you're going to shift up. You're going to shift up 2. All right, so we come over here and we're looking for perfect cubes. And the reason why you use perfect cubes because you want to use whole numbers. You don't have to want to guess decimals. All right, so we know the so when you use excuse me, if it's an even or if it's an even root, you can only have positive outcomes. If you have an odd root, which is 3, you can have negative and positive solutions. All right, so we're gonna do a negative. We're gonna choose a -8. So remember, a -8 is a perfect cube. So that's a -2 cubed, which is a -2 times -2 times -2, which is going to give you -8. All right, so the cube root of -8 plus 2 is simply -2 plus 2, which in this case will give you 0. All right, so we have, and notice now you want to do oh, well, I'm sorry. All right, now. All right, so now if we do Janelle, so now we want to use -1. So the third root of -1 plus 2. So the third root of -1 is just simply -1 plus 2 equals 1. Then we plug in 0. So that's going to be the third root of 0 plus 2. And that's going to give us just 2. And then we can use 1. And so the cube root of 1 plus 2 is equal 1 plus 2, which is equal to 3. Then we're going to do 8. The cube root of 8 is just going to be 2 plus 2 is equal to 4. So with that, hold on for a second. Yeah. 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 Okay, Ash. All right. So when you do this one, it's going to be it's continuous function. So when I do, you want whole numbers. So let's say if I wanted to pick, so if I want an x to be 3, it's going to be a decimal. But since I have the main points, the whole number points, if I just connect them, it's going to hit that line for the most part. It's going to have that function, and it's a continuous function. So, Ms. Mabry, that makes sense to you now? All right. So, what other questions do you all have from the homework from last night? So, if 2 is the only one. If 2 is the only one, we need to move on to the rest of this lesson. Because we talked about absolute value yesterday. We talk, and I got to talk about piecewise today. We got to talk about step functions. All right. Okay, so number 8 and number 3. All right. So I'm gonna go ahead and erase this one, and we'll do 8 and 3. All right. So if we look at number 3, you're gonna come over here for 3. You have f of x is equal to the third root of x plus 4. So basically, what you're doing here, this is going to be your shift. So if you want to see what your shift is going to be, in the x shift in the x direction. So you're just gonna set x plus 4 equals 0. So that's therefore x is equal to -4. So you would do this as if you're doing a parent function, but you're just gonna shift it 4 spaces to the left. Now, you want to do whole numbers. You want to say what third root can I plug in here to make my third root a even number? So we're going to come over here, and we got to figure out what can we do to make this a perfect root. So I'm thinking, I know -8 is a perfect cube root. So I got to say, what I'm going to plug here to make this up under here -8. So I'm going to try -12. So if I do the third root of -12 plus 4, that's going to give me a -8, which we know that's a -2. Now, what other number could I plug up under here? We know we have what? We need a -1. So can I put a -5 here? So a -5 plus 4 is equal to the third root of -1, which is -1. Now, in order for this to be 0 up under here, so I'm going to use a -4. So a third root of -4 plus 4 is equal to the third root of 0, which we know is 0. So now I need to make this a positive 1. Okay, so what I want to do here to make that a positive 1, I'm going to use -3. So the third root of -3 plus 4 is equal to third root of 1, which is just simply 1. Then I got to say to myself, what can I do to make this up on here equal a positive 8? So I'm just simply going to put 4, the third root of 4 plus 4. That's the third root of 8, which is 2. So I have all my whole numbers. Okay, so now all I need to do is simply graph it. All right. So I have what, a negative 12, negative 12, negative 2. It's right here. It's approximately, so right here. Then I have negative 5 is negative 1, which is right here. And then I have what, negative 4 is going to be 0. Negative 3 is going to be 1. And 4 is going to give me what, 2. So this is a cube root. It should look like this. And that's your function. Any questions on number 3? Yes, no, maybe. Okay, what do we need? What do I need to talk about? So you don't, oh, no questions? Okay, good. What about you, Mark Charles? Charles, you have any questions? Okay. All right, cool. Miss Mabry, questions? All right, so let's keep it moving. So let's go to number 8. All right. So number 8. All right. So for number 8, we have the third root of 2x plus 9 plus 6 equals 8. So now, if you're working this problem out, your root has to be isolated. So you can't cube both sides yet because you have to get rid of this. Okay, so we know if we subtract 6 from both sides, that's going to give us 2. Now we have the cube root of 2x plus 9. Now you have the cube root isolated, sitting by itself. You have the other side over here. So now you can take the cube root. You cannot take the cube root of both sides if you have something outside of the radical. You have to move it where the radical is alone. Okay, now we have it alone. Now we have the cube root of something. So in order to get rid of the cube root, we have to cube it. Remember we talked about your power divided by your root? So now we're going to left with 2x plus 9. And we know 2 to the third is 8. So now we simply just go into 2 steps. So we got 2x is equal to, what, that's negative 1. X is equal to a negative 1/2. But remember, we got to check in the original problem to see if it works. So we're going to do the third root of 2 times negative 1/2 plus 9 plus 6. And it should equal to 8. So if we take the cube root of negative 1 plus 9 plus 6 is on the outside, 8. So we know this is the cube root of 8 plus 6 is equal to 8. We know this is 2. 2 plus 6 equals to 8. That checks. So therefore, negative 1, x equals negative 1/2 is a solution for the function. All right. All right. So we just so any questions on the other problems, or we're good? If not, we're going to go ahead and do piecewise, and we're going to do step function. Okay, good. All right. So any other questions on the homework I gave you all? Okay. All right. All right. So what you need to do is get your packet out, and we're going to talk about. We got to talk about. Well, you don't need your packet right now. Okay. So I'm going to show you how to do. Yeah, but get it out but I'm going to do piecewise first because piecewise is easier. I think it's the easy of the two. Step function. It'll take a minute. Okay. So I'm going to go ahead and erase this, as you all understand. All right. So we're gonna do piecewise. So what they mean by simply is what it is. You're gonna take pieces of an equation. Oh, number 11. All right, we'll look at 11. Oh, so 11 is the absolute value function. All right. So what you want to do, okay, so when you do an absolute value function, it has a vertex. So it has a center just like a quadratic function. So what you want to do here, you're going to come over here and you're going to set this equal to 0. So you got 3x plus 3 equals 0. So that's simply just going to be x equals -1. So this is going to be, so this right here is the vertex or center of your graph. All right. So what we want, since I know this is -1, I'm going to come here and I'm going to do x and y. And I'm just going to pick 2 points on either side of it. So my center is going to be, my x value for my center is -1, -2, -3, 0, and 1. All right, so basically what you're doing here is kind of like a linear function, but it's a V shape. Okay, so what we want to do here, so when we do this, these two y's are going to be the same. These two y's are going to be the same. And this is going to be the very center. Okay, it's the packet I gave you for 19. The last one is 21, which you did your homework on. I mean, not your homework, but what we talked about yesterday. All right, now, all right, so if we do this, we're going to plug in. So once we find what this center is, that's going to be the shift. Okay, so what we want to do here, we're going to do 3 times -3 plus 3, the absolute value plus 2. All right, so when we work that out, that's going to be, so this is -9, -9 plus 3 is -6. So we got absolute value of -6 plus 2. But we know the absolute value of anything is positive. So we should get 8 for an answer. All right, now come back. We're going to plug in -2. So the absolute value of 3 times -2 plus 3 plus 2. But we know that this is -6. -6 plus 3 is -3. But the absolute value of -3 is 3. So we have 3 plus 2, which is 5. Then we plug in -1. So we got 3 times, negative 3 times -1 plus 3, absolute value, okay, plus 2. But we know this is 0. So this is 0 plus 2, which is 0. And then we should get this. This should be 5 when we plug in 0, but we'll do it anyway. So 3 times 0 plus 3, absolute value. So that'll be 0, absolute value of 0 plus 3, which we know is just 3. And here outside we have that 2. So that's 5. And then absolute 3 times 1 plus 3, 2. So we know 3 plus 3 is 6. Absolute value of 6 is going to be 6. So we basically just have 6 plus 2, which is 8. If you notice, this is your very center. So it's simple, like I said, it's similar to a quadratic function, but it's a V instead of a U. So let's go ahead and we can graph this. All right. So we have what, a negative 3, 8. So that's what it should look like. Again, your quadratic function will be a U shape, but anytime you have an absolute, so this is the absolute value function. So it should look like a V. Okay. Jamar, makes sense now? Now, if you were graphing this, if I just had, so g of x is going to be, so this is your parent function. So if this is the parent function, the center would be 0, then it'd be 1 to 1, 2 to 2, 3 to 3, negative 1, 1, negative 2, 2. But since I have this, I solve for this, that function just be shift. It would just be shift back 1 and up 2. And so that's what that is. Okay, cool. All right, so now we got to talk about piecewise. So I'm going to go ahead and erase this. And also, this is in the on the blog when I worked it out. So if you have, so we got 3 functions. So now we're going to talk about piecewise. In other words, you're only taking a piece of the function. Okay, so let's say we have y1 is equal to a negative 2x plus 3. And then for the second function, we're going to have we're going to have x plus 1. Well, we'll do two pieces of it. Okay, now, so we're going to graph this. All right, so these are the two functions, y1, y2, but then this is going to be our piecewise function. So in other words, we only want a piece of each one of these. We only show a piece of each one of these functions. So you know what? Let me make it a different color. So we're going to let this one, the first one, be black. And let the second one be blue. All right. So we're going to graph like we normally do for this. I guess I need to use the blue because it's darker. All right. So if we were to do this, so this we plug in -3 here. So that's going to give us what? -6. So we got -6 plus 3, which is -3. Then we plug 2 in here. So that's -4 plus 3. It's going to give us what? -1. We put -1 in here. So it's a -2 plus 3 is equal to 1. All right. So we're going to go ahead and we're going to graph that. So we'll come here. All right. So if we do -3, so that's going to be right here. And then if we do -2, we get -1. Then -2, -1, I'm sorry. And then we plug in -1, we're going to get 1. What did I do? So if I plug in -2, so that's -4 plus 3. So if I plug in, what am I doing? I'm sorry. This is not right. I apologize. All right, so if I plug in -3, that should give me 6 plus 3, which is 9. I plug in -2, that's 4. So that's 4 plus 3 equals 7. And then there should be 2 plus 3, which is 5. And I should have known this because this slope is negative, so it should be going down as I go to the right. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. All right, so a negative 3, 9. So a negative 3, 9 should go right here. A negative 2, 7 should go here. A negative 1, 5 should go here. All right, and then normally if I put in 0, that should give me 3, right? But we're gonna put an open circle at negative 3. So 0, we're gonna put an open circle right here, and we're going to, because we only want from negative 3 to 0. So we only want a piece of the function, not the whole thing. Oh, sorry. All right. So we only want just a piece of it. So now we're going to come to do this one. So the starting point for this one, 0 would be 1, wouldn't it? So that'll be 1. And then if I plug in 1, that'll be 2. Then if I plug in, so if I plug in 2 here, that's going to be what, 3? But it has to be open. So this is going to be your graph for and this should be a straight line. Let me fix that. So that's your piecewise function. All right, so these are the two functions that you have, but the piecewise function, you only want a piece of the function. So this is the piece for negative 2x plus 3. This is the piece of the function for x plus 1. Kind of make sense? Yes, no? Because we can do one more. Okay, I got you. All right. So we're going to do another one. So we're just going to write this notation for a piecewise function. And you're going to do this in pre-calc, and you're also going to do it in calculus. We won't do it in AP statistics. All right, so we're going to do, all right, so we're going to do a negative 2x plus plus 5, and we're going to do x squared. So no, and we're going to do, and our restrictions is going to be that x is greater than or equal to. So no, let's change this to a negative 5. And then we're gonna make this x is greater than or equal to a negative 4. No, sorry. You get this one. All right, so I cannot get this one. So we're gonna have we'll just do that one. Okay, so what we're gonna do now, we only want a piece of it. So we're only looking for this one, we're only looking for between negative 4 and we could find the answer for 0, but it's gonna be open. And then we're just gonna plug, we can find like 2 or 3 points for this one. Well, we could do 3 of those. And so this is continuous. So let's look at, so if we look at the first one, x is xy. So we're going to try negative 4, negative 3, negative 2, negative 1, and 0. Okay, so if we plug in negative 4 here, so that'll be negative 2 times negative 4 minus 5. So that's going to give us 8 minus 5. And that's going to give us what, 3? And then we have negative 3. So that's a negative 2 times negative 3 minus 5. 6 minus 5 is going to give us what? 1. Then if we plug, since we know this is a linear function, so wouldn't this just be simply negative 1? Because if we do a negative 2 times negative 2 minus 5, that's equal to 4 minus 5, which is negative 1. Then we plug in negative 2 times negative 1 minus 5. So that's going to be 2 minus 5, which is give us a negative 3. Okay, negative 2 times 0 minus 5 is just minus 5. All right, but it's going to be open at 0, negative 5. So we're going to come here, and so we have negative 5. So all right. So we let's try. So we have a negative 4, 3, right? So negative 4, 3. And we have a negative 3, 1. And we have a negative 2, negative 1. And we have 0, -5. Oh, -1, -3. And then, so since 0 is not included, we're going to put an open circle here. Then we're going to connect this linear function. Because the reason why they call it a piece function, because we only want these pieces of this linear function. Now we got to find the pieces for x squared. So we know that if we plug in 0, 0 squared is 0, right? We plug in 1, 1 squared is 1. We plug in 2, 2 squared is 4. And so our graph, since is continuous to the right, that's your piecewise function. So this is going to be x squared, and this is going to be a -2x minus 5. And we put restrictions on it because we only want just the pieces. Oh, where does -4 come from? Because this is a restriction that you put on restrictions. This is -2x minus 5. We only want you to find the solutions between -4 and 0. But the solution for 0 is not included. Remember, we got an inequality? Then here, they ask you for just find the pieces where x is greater than or equal to 0. So when you take pre-calc, especially you take pre-calc and calculus, when you're doing a piecewise function, they're going to only ask for a certain pieces of the entire function. So now if I want an entire function, this would just be a linear function that's going in infinite directions to the left and to the right. But if I was doing this one as a whole function, it would be a complete quadratic function, but I only want pieces of the function. And they're going to give you your restrictions in the very beginning. So you're going to see it just like this in Algebra 2. You'll also see it just like this in pre-calc. You'll also see this like this when you take your calculus class. How do you find it? You just plug in the answers. So you're going to plug in x is equal to -4, x is equal to -3, x is equal to -2, x is equal to -1, x is equal to 0. Okay, but this is open, so it has to be open at x equals 0. So you just found all these solutions. Now for this one, they saying that you want your x to be, so if I'm doing x squared, they simply want, so this is for this. If I wanted my x squares, and they want us, the lowest point is 0. So I'm gonna put 0. We know that 0 squared is 0. Plug in 1. We know 1 squared is 1. We know 2 squared is 4. So since this is continuous to the right, it goes to, as x goes to positive infinity, as it goes to the right, because they didn't put it, so this goes on forever, right? So you got to put this arrow here, let you know it goes on forever. So basically, you want all your y values to the right of 0, include 0, which is this. That's the only piece they want of this entire function. Okay, for this linear function, they only want the pieces from -4 and 0, but 0 is not included. Again, they give you the point, give you the x values where they want you to be restricted to. So they're telling you, I don't want answers for, I don't want solution for x equals -5, x equals -6. I don't want a solution for x is equal to 0, x is equal to 1. I only want the solutions from -4 when x is -4 and x is less than 0. That's the only part of this linear function that I want. That's what they're asking you. Then for this one, I don't want the whole entire quadratic function. I only want the solutions when my x value is 0 or higher. That's it. Okay. So that's your piecewise function. All right. So any questions so far? Okay. So again, that's why they call it piecewise, because they only want a piece of each function that they're asking for. Miss Mabry, does it make sense? Jamar? Yeah. Yep. This might be G of X, P of X, R of X, A of X. It's going to be something. They have to name the function. They have to give you the functions, and they have to give you restrictions for the functions for these functions. So this is actually two functions, but this is the entire function for that represent all these different functions. So they only want a piece of each one of these functions. They want you to put all the pieces on one coordinate plane. Because if you think about it, how are you going to find these pieces if they don't tell you what your function is, which is f of x, and what part of the functions they want to find? All right. Make sense now, Mark Charles? Okay, good. All right, Ms. Mabry? Waiting on you. Are you still here? So, Jamar, is that yes, you understand it? Or yes, but you need me to do another one? Okay, cool. All right, so I'm gonna go ahead and show you how to do step functions. You got to be real. You got to pay attention to step functions. And we're gonna do at least 3 of these, minimum. So you have what's called your. So we talk about step functions now. All right, you have what's called your floor function. or they may call it your greatest integer function. All right. And so it's going to be written like this. You're going to have y is equal to all right. So, and the thing with this, with your floor function or your greatest integer function, everything is going to be represented by an integer. Okay. So if you're going to come here, if I wanted to graph this, I'm going to come here and I'm going to do X and Y. Well, I guess I can just do the graph. Let me show you. And this is called, you. And when I'm done, you'll see why they call it a step function. And you can continue this if you want. All right. So this is your floor. So when you do that, that means, so I'm going to come here. If I have, so this is going to be 0. So I'm going to start here at 0. So if I plug in 0, that's going to be 0. If I plug in, and so if I plug anything in between here, because it said integer, so your solution, everything is going to have to be an integer solution. So all your y's must be, all your y values must be an integer. Okay, so I have to include 0. That's because it's got my floor. Then I'm gonna put an open circle here. So any number, any value for x in between 0 and 1, I mean 0 but less than 1, it's going to be 0. Now, so I'm gonna come up here and I'm gonna start at 1 because that's my floor. And then from 1 less than 2, long as I'm in between these values, that's going to be all my y values. All my y values, like I said, has to be an integer. Now, if I go up to the next one, I'm going to go here and I'm going to, so I'm going to go up here to 2. Since that's my floor, I'm going to close that. Then I'm going to go to the next number. I'm going to open it. Then everything between 2 but less than 3, the value has to be 2. Then if I'm going backwards, I'm going to come here. And if I'm looking at x equals -1, I'm going to put a closed circle here. So everything between -1 but less than 0, all the y solutions have to be -1. So if you think about it, would this be steps if I was connect these? If I go here, 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 so wouldn't that just be steps? So that's why they call it a step function. Oh, and this is your parent function. So this is your parent function for a step floor function. So I'm gonna let you write that down, and then we're gonna do a couple things, a couple different examples of the floor. Then I'm gonna show you how to do the ceiling function. Then we'll be done. So if I want to do this one, if I want to come and do this one, you can. This goes on forever. You don't have to do a couple of them. So this is going to be open, and you can just keep going step by step. It's continuous. All right. Give you a minute to write that down. Then now we're going to have to do, I'm going to do two more examples, how to do this after we're done with this. But just remember, all your answers Y values have to be integers when we do this problem. We do these type problems. Okay. All right. So I hope you have time. I hope you have this written down. So I'm gonna go ahead and do another. I'm gonna do another one. All right. So now we're gonna do f of x. Let's just change it. So we can do p of x. So p of x is going to be 2 ceiling x. So now what we're going to do now is, since your y value is going to be doubled, you're going to come over here and you're going to graph it like so. So he's actually quiet over there, which is a good thing. Shocked. All right. So what we want to do here, since this is ceiling, okay, so what we're going to do like we normally do, since this is 1x on the inside. So we're going to put a closed circle here, open circle at 1. Then we're going to, that's it for here. But your y is twice as big. So instead of going up to 1, we're going to go up to 2. Put a closed circle here. So this is 1, 2, 3. And so we're going to go over here, open circle. Since your y is twice as big, now you want to go up to 4. Close your circle. Go over to 3. Open your circle. Because you're only going distance-wise, x direction. You're only going one space because this is 1x. But we just doubled our y, so we got to go twice as high. Then if we're going backwards, we'll go down here, and then this will be open here. We'll go back to -2. That's going to be closed here. Oh, hold on. Yeah, that's right. So if I go to -1, should be open here. And close here. And then I could go down here, open here, Go over to -2, close it. And you could just continue that. Okay. Questions? Okay. All right. All right. So we're going to do one where we're going to do the inside. So now if you do the inside, okay, so we're going to come here. And remember, we got to have we want our y's to be integers. All right. So in order for me to solve this problem here, if I'm looking, I can do 0. And I need to go to, now to make this equal 1, I have to go to 1/2. So this would be 1/2. This would be what? This would be 3/2. And this would be, I'm sorry. And this would be what? 5/2. All right. So I can only go, since this is my ceiling, I'm going to go open this up. And then if I go here, I'm going to do, so I got to plug in. So in order for this to work, I need to plug in, hold on for a second. Yeah. Just wanted to make sure before I did it. So I'm going to open this, and then I'm going to go up 1. I'm going to close this. Then I'm going to open here. And the reason why you do that, because you want this to be a whole number. So if I plug in 1/2 times 2, that'll give me 1, wouldn't it? Okay. Then now I'm going to go here. So this would be a -1/2. So I could just simply open this up, and I'm going to close this at 1/2. You say to yourself, what can I plug in here to make this a whole number? So that is how, and you could continue this if you want. You can go up here, close this, and you're going to stop at the halfway point. Open this, and that, so, and you can just keep going either direction, and that's your step function. Now, only thing we have left now is the ceiling function. So instead of having you just brackets on the bottom and the open brackets on top, it's gonna be switched, and we're just gonna shift this backwards. But I'll do example though. Then we'll be done for the day. Okay. Wait for questions if you have any. All right, cool. All right, so let's go to the next one. So now we're gonna do the ceiling function or your least integer function. And this is written so that's how your ceiling or least integer function is written. Okay. And this is your parent function for your ceiling function or your least integer function. All right, so we're going to graph this. Remember again, all your y values are integers. In other words, whole numbers. Now, so we're going to graph this. All right. So when you do your ceiling functions, okay, so what you want to do here, you want to do, know how we did, we had zero closed here. Well, your zero is going to be open here. And then you're going to have, make sure I do this right. So if I do zero, so what you want to do here, you want to do, this should be open. This should be closed. And then here, this should be closed. And this should be open. And I'm gonna explain why in just a second. All right. So in other words, the reason why this has to be closed, because this reason why they call it a ceiling, because your highest value is going to be zero at zero. So if you go one back from -1 to 0, it has to, zero is the biggest value. So it's the highest value it can be at 0. Then if you go 1, at 1 itself, the highest value your y can be is 1. So between 0, greater than 0, up to 1, your value is going to be 1. So if then here, I'm just going to go up here, put an open circle here, and I'm going to go to 2. because 2 is your ceiling at 2. That's the highest values can be. So everything below it has to be everything below it. So from 2, but not including 1 in that area, that's going to be in that interval, that has to be 2. So if I want to do -1, -1 is the highest value it could be at -1. So I'm gonna close -1. I'm gonna go and open 2, and then this is my ceiling function, because the highest value at -1 has to be -1. So I got to go back one space, because this is 1 here. Because this is 1 here. And so between here, that distance between here is 1. So I got to go back 1. And everything from back 1, I can't include -2. And I'm going to go up to -1. All those values in between there has to be -1. So that's the difference between your ceiling and your floor function. Any questions? We don't have any questions there. Ooh, everybody. Oh, I thought it was 0. Okay, so if there's no questions, we're done for today. So, and I will put on a remind what you're supposed to do on the blog. So we are done with chapter 4 or unit 4. We're done with unit 4. So I'm going to, and I'll put on a remind how we're going to turn some stuff in, because we need to do some quizzes to see if you understand the material. And we need to do a test to see if you understand the material. But we're going to quiz we start quizzing Monday. So what I want you to do, I put on a remind what I want you to do those problems. Then I'll put an answer key tonight, and I'll see you all Monday. But I'll put that on the remind as well. Okay, if we don't have any questions, I'm out of here. All right, you too, my man. All right, any questions? Jamar, you good? Okay, have a good day. Okay, no questions? Outstanding. All right, thank you all for joining. See you Monday.